Hey guys, welcome or welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2004, 10A, Problem 16, and it deals with geometry. I hope you guys enjoyed this video and let's get started. The problem states the 5 times 5 grid shown contains a collection of squares with sizes from 1 times 1 to 5 times 5. How many of these squares contain the black center square? Okay, essentially what we're trying to do is we're trying to find how many squares contain the black square. So we can actually divide this up because there are only so many different sorts of squares that we can count. So first we can start off by the 1 by 1 squares. So how many squares are those that are 1 by 1 and contain the black square? Well, there's only one, which is the black square itself. And then 2 by 2s. 2 by 2s, it could be any of the 4 squares surrounding the black center square. So I'm saying this one, or this one, or these 4, or these 4. Because these are all 4 by 4s. Or 2 by 2s, and they all contain the black center square. So there would be 4 2 by 2s. And then 3 by 3s. So this is going to get a little bit trickier, but essentially it's going to be like this. There's going to be one 3 by 3 square right here. And then here's the thing, because if you're only going for the 4 edges, like the 4 edge squares, then you're going to miss out like the center ones. So my tip is to just move horizontally 1 by 1. So we already have 1 square right there. And then move over 1 to get this square. That's also a 3 by 3, and that also contains the black square. And then move over another 1 to this square. And then we see that that's it for that line right there, because if you move to right here, then there'll only be 2 squares. And then you can repeat the process. So we have 1 down here, 1 right here, and 1 right here. Okay, so right now we currently have 6, 3 on each side. But then don't forget, so that's just going this way, right? We're starting right here and we're going this way. But what about going downwards? So I'm going to erase this. And going downwards, we have, because we can't count this one again, because that's already counted towards that side. So we're going to start off with this square. Okay. And then we can move over. So we have this one. And this one. So that's 3 more. So we initially had 6 going horizontally, and that's 3 more. And that is it. So we have a total of 9 right here. And so you see how we didn't like leave anything out or miscounted, because we went from this, and then we went this way, and then we went down all the way to the corner ones. We started out with the corner ones and then went this way. And then we left out the middle line, like the middle segment was that way, and then we had 3 as well. So you have a total of 9. Okay, and then now let's go to 4 by 4s. 4 by 4s is not as tricky because there's not as much. So we can start off always with the corners. 1, 2, 3, 4. So that is 1. And then again, you can move this way. So we have this. And then you see that you can't move to here because if we go from here to this way, we only have 3, so we're running out of space. So going horizontally, starting from the upper left edge, we only have 2. And then we can go to, so we have 2 right now, and then we can go to the bottom corners. So also moving horizontally from the bottom corners, we have this square, and then moving to the right, we have this square. So again, we have another 2 more. And we don't have to worry about miscounting or forgetting to count the center rows because this is 4 by 4s, and so we would not need to do that because the center parts will only apply to the 3 by 3s. So for 4 by 4s, we have 4. And then lastly, 5 by 5, which we only have 1, which is the whole entire square. And now all we have to do is just add this up. So 4 plus 4 is 8, 1 plus 1 is 2, plus 9 gives us 19. So the answer is D, 19.